And I'd like to introduce Ionel. He is the Chief Technology Officer at Amprius, and I believe for 14 years already with the company.
Yeah.
And he will be talking about Amprius and how they are transforming the e-mobility sector. Take it away.
Yes, thank you. Thank you for the introduction. Today I'll continue basically the silicon topic that was opened by the previous speaker. Um, the in this case, with focus on electric mobility. So update I presented about 2 years ago, I think, at this conference. Um, Amprius has a much longer history. We started in 2008, and by 2014, we have developed a 3D structure uh, for pure silicon anode use. So, as was presented before, silicon is probably the most desirable anode material because it has the highest capacity to store lithium. However, as particles, as typical anode and cathode materials, in the shape of particles, silicon doesn't work that well. So companies have started looking at other shapes, either films or, in our case, a 3D structure. This 3D structure in the shape of silicon nanowire. By 2016, we had developed a manufacturing process integrating all the steps to make this type of 3D structure. And by 2018, we started delivering cells to our first customers, Airbus, which in 2018 already set a new record of continuous flight with our cells. In 2021, we started our large-scale manufacturing project in Colorado, and in 2022, the company listed publicly on New York Stock Exchange with funding for scaling up for manufacturing. So in Colorado, we have a location, the largest building of one-story building in Colorado, in Brighton, is now leased for long term by Amprius, and we started a gigawatt-hour scale factory there. Of course, it will take years and steps. So in 2024, the precursor to that is the equipment that we installed in Fremont, and that type of equipment and even larger scale will be installed in Colorado in 2025, with capacities projected to extend to gigawatt hour by 2028. So to answer of course, how do we make it? We make the cells in very similar way as a standard battery industry. So we don't invent most of the line. And for the anode, we actually combine with solar industry equipment. This is already available in a large scale, is tested for years now. So we adapted it to battery manufacturing. So overall, these are all at about the same scale, at hundreds of megawatt hour and gigawatt hour scale, available in already in automated lines. The advantage of this type of equipment is that it replaces multiple steps. So as a footprint is much smaller. It takes about 20% of a standard anode line, for example, just to manufacture the anode foils. Going back to basics, again, we're not replacing the entire battery, we're replacing the anode. And the standard anode materials, graphite, have a capacity of about 372 million power per gram. And they store lithium at the highest ratio of about 1 to 6, so 6 carbon to 1 lithium. By replacing it with silicon nanowire, we have now a material that is about 3,600 million power per gram, and it stores 3.75